All right. So for this warm up for today, right, we need to remember the three equations that we have studied, the three basic ones. I is equal to PRT, which is what we call the simple interest. Okay. We also have the compound interest. We also know this as the future value. Okay. And that goes and finds the amount of money that we're going to have in the future. And finally, we have this, which is what we call the present value for the compound interest. Now, today's warm-up is to choose which one of these three we're going to use for this problem. George is investing $1,000 for his granddaughter's education, right? In an RESP. So that's what we call a registered education savings program. That allows people to save money for the future, but not having to pay taxes on it while they are saving up for that money. So the moment that it comes out, as long as it's being used for education purposes, the government cannot get access to that money or tax it. Okay. Now, this RESP pays an interest rate compounded daily. So based on that, we cannot use this one, the simple interest calculation. So we have to use either this one that talks about the future value, the value of our compounding in the future, or our present value, finding out how much we need today in order to make the money that we want in the future. Now, in this case, he's investing $1,000 now, and he wants to know how much will the money be worth after 15 years if it's compounded daily. All right, so the first thing that we're going to do is we're going to start by addressing the fact that we're going to use this equation for compounding. Okay, the reason why we're doing that is because we need to know the money that we are going to have in the future. So in order to do this calculation, what we're going to do is we're going to first start by coming up with our APIN. And in this case, we do not know what the amount of money we'll have in the future is going to be. We do know what our starting amount is, which is $1,000, right? Now, we do know what the interest rate is. We said the interest rate was 6.5%. So 6.5% is 0.065. And the number of years is 15 years. Now, you remember what I told you about this. When we're compounding something daily, right, what we have to do is we have to take the rate and divide by the compounding number, and then take the years and multiply by the compounding number. So when we divide, so when we're compounding daily, we're actually compounding by 365 days in 1 year. So that means we have to take 0.065 and divide by 365. Okay. Now, when you divide by 365, you're going to get some crazy long number. And that crazy long number is this one. Now, you could leave I as a fraction in your P1 plus I to the n calculation, or you could use this number that we have here. Okay, nothing's wrong with that. But now we have to take 15 and we have to also times it by 365. So you're going to get 5,475 compounding periods. So now let's go and do our calculation for a p1 plus I to the n. So as usual, we always start by writing out our basic equation, then we do our substitution. And we have this for our substitution. Now let's simplify a little bit to make the calculation a little easier before we put it in our calculator. And we end up with something like this. And then we just punch that directly into the calculator, and you end up with $22,650.91. So in order to answer this final problem, you just have to say the following. So there's going to be $2,650.91 in the account in exactly 15 years if we compound that money daily. So now that we've done this future value problem, let's go and try and see if we understand this present value problem that I have here. Okay, here's the problem. We're going to call this part 2. So Kinsey wants to buy a car in 3 years. Okay, now the fact that she wants to buy a car in 3 years, she has to have a total amount of money that she wants to have at the end of those 3 years. In this case, she says she wants to have $2,000 saved as a down payment. So we want to know how much she has to put away today at 6.5% weekly. So we have to figure out which one of the equations we're going to use. All right, so this is a compounded problem, right? So that means we can't use the simple interest type problem again. Now, we're not asking about how much we're going to have in 3 years. In this case, we're actually looking for how much we actually need to have today in order to accumulate up to $2,000. So that's this equation. So when we're looking for how much we have to invest today to get a certain amount at the end, this is what we call present value. So now let's start by identifying APIN. So now we know that we start with $2,000. No, we want to end with $2,000, right? We don't know what our principal is. We do know what our yearly rate is. So the yearly rate is 6.5%, which is 0.065. And we do know that the number of years is 3 years. The only issue that we have to deal with is the fact that it's being compounded weekly. So you got to remember that the number of weeks in a year is 52. So we have to divide 0.65 by 52, and we have to multiply 300. We have to multiply 3 times 365. Now, I'm going to show you how you can do this on your calculator really nice, where you don't have to find the decimal of 0.65 divided by 52. We just plug it in. And we have 3 times 365. Let's just get that calculation really quick. And so we end up with 1,095 for 3 times 365. And remember, we're going to actually leave that I value as a fraction in our calculation now. Now, for the old way, what we would do is something that looks similar to this. And what we would have done for our decimal is we would literally have just calculated the decimal to be 0.00125, and we would plug that in to our equation, and we get the final answer right here. Okay, now that's all well and good, but this is how some people tend to solve these problems. So we'll call this the new way with no decimals. So you start with A is equal to P1 plus I raised to the negative N. Now, we already have most of the work done. So we write A is equal to, well, 2,000 times 1 plus, well, we're going to write 0.065 divided by 365 in the brackets, raised to the negative 1,095. And all we're going to do is we're going to punch that exactly as you see in your calculator. So you're going to put 2,000 bracket 1 plus 0.065 divided by 365 and bracket x to the y, and then negative 0.1095. Now, this is how it would look like if you typed it on the calculator. Now, just like we practiced before, we always put a bracket around the thing that we're going to do the y to the x part to. All right. And once you punch that in, you're going to get the exact answer again. A is equal to $1,645.86, which is what we expected. So to answer the final question, you're going to say, therefore, she should invest $1,645.86 now. So today's lesson is very important, right? We want to know what happens in the future with our money, all right? So we are going to go and take a look at what happens with this equation when we vary the rate and the time on the final investment. We want to know what happens if we start with a certain amount and we change the time or the rate of the interest. Things like, what would happen if we double the rate but kept the interest, kept the years the same? What would happen if we, say, increase the length, the time it takes to do all this stuff, right? Or what would happen if we, say, change the time, the end value to be, instead of doubling the interest rate, maybe what you're going to do is you're going to change the compounding periods, okay? And that will help us see what happens to a compounded value over time. So let's take a look at this first problem here. This problem says Kate invests $8,000. Okay, I'm going to underline all the important stuff in red. She invests $8,000, and it's 8.9% compounded annually. So when you hear the word annually, the number that we're multiplying is by 1, which is just 1 year. Oh my God, that's 1 year, right? So we have this for our calculation. So we have A, we don't know what it is because we want to know how much it's worth after 5 years. So we have P equaling 8,000. We have 8.9% is just 8.9 divided by 100 gives us 0.089, and N is 5. And this is what we get for our calculation, our basic calculation. And then what we're going to do is we're going to make sure we understand how much interest we make. So start by with subbing your equation in, and then we take a look at what our total amount is by just punching into this equation, and we end up with this as our final answer for A. So we find out that we're going to get $12,252.63 in 5 years based on what we know. So now let's take a look at this question that we have here. What do you think will happen if we double the interest rate, right? Do you think it'll double your final value? Some of you will say yes, some of you will say no. But everybody thinks that they might get more money, right? So let's just say answers may vary, okay? So now let's calculate the value of the investment. If we use the same the same A's, but then we double the interest rate. So basically we've got A again, 8,000, but this time we're going to times the 0.89 by 2 to get 0.179. So now let's take a moment and let's zoom in on this information and do the math together as a group. So here's the rule. So we're going to say calculate the value of the investment. We're going to do the same APIN calculation as before, but this time our I is going to be 0.179. Whoops, that should be 0.178 as our final answer here. Okay, so now let's just do the substitution into APIN. So we got A equals P 1 plus I raised to the N. Substitute directly in, you got 8,000 times 1 plus whatever, but it's really just 1.178 raised to the 5. And we end up with A equaling 18,147.48. Wow. So now when we take a look at what we had from before, something's interesting here. You'll notice that we made a lot more money here. Okay? All right, so let's go and take a look at what the final question is. It says, what's the impact of doubling the interest rate? Did it double? Did it double the amount of the interest earned? Well, the final amount was not doubled, okay? It wasn't doubled. All right? But let's take a look at what the interest earned for each of these things was. So here's how we calculate the interest. I is equal to A minus P. So we're just going to calculate that for each one of these. Now, let's just quickly do that. So when we calculate the interest for the first one, we end up with $4,252, right? So now let's go and do the interest for the second calculation where we doubled the interest rate. And now for the second calculation, we end up with $10,147 for our interest. So in this case, what you got to realize is when we're talking about the interest earned, you got to understand when we double the interest rate, we more than double the interest earned. Yeah, man, that's really good. That's really good for making money. So if I get double the interest rate, I'm going to get more than double the interest. Okay? Now, let's go and take a look at what would happen if we change the length of the investment. Okay? So let's do those calculations again based on what we had before. Okay? So remember, we originally started with this calculation where it was 8.9% for 5 years, blah, 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 right? So imagine if we take what we have here, okay, and now what we're going to do is we're going to take our conditions that we started with at the beginning, all right, and what we're going to do is instead of doubling the rate like we did before, this time imagine we're going to double the number of times that our money is compounded for. So we're going to go and look at the length of the investment, and we're going to increase it from 5 to 10. So instead of 5 years, we're going to have 10 years. What do you think will happen? And then we'll make sure that we calculate the interest for that and see what happens. All right. So now, let's see. Let's ask ourselves, what do you think will happen if we double the length of the investment? So the question is, what do you think will happen? Just write down your ideas. Do you think it's going to double? Yes or no? It's up to you. Okay? Do you think the money's going to double or not? All right. So now let's go and show the calculation for this. And now when we do the appropriate substitutions, you're going to get A is equal to $18,765 and 87 cents. All right, so that is how much we have. Now, let's just go and do an interest calculation. Let's see how much interest we made. So remember, interest is equal to the final amount minus the initial amount. So we have 18,765.87 minus 8,000. So we're going to get 10,765.87 as our interest using this scenario. So your question should be, what we want to know is, what was the impact of doubling the length of the investment? Did it double? So the final amount is went from 12,252.63 based on the original, and then it went to 18,765.87, right? You got to understand this was not doubled. And let's talk about the interest earned. The interest. So for the interest, when we talk about the interest, we went from 4,252.63, and it turned into $10,765.87. And what happened for the investment? It more than doubled. When we increased the years by 2 times. We more than doubled when we increased the years by 2 times, and we also more than doubled the interest when we doubled the interest rate. So now let's move on to the last concept of the day. All right, so for this problem, we have Kevin. He wants to invest $4,000 for 15 years. How much will it be compounded at 6.5% annually, quarterly, monthly, and then weekly? We can do this really easy. Just write our APIN for each one of these, and then we just plug into our equation. Now remember, our equation is A equals P 1 plus I to the n, right? The P is always going to be 4,000 for each one of these. Okay, the I value is going to change. So the first one is 6.5% compounded annually. So we don't have to divide by anything. So we end up with 0.065, and N is 15 years, right? So this is what we get. So we end up with 10,287.36. So now let's do this again. Instead of what was it? Annually, this time we're going to do quarterly per year. So when you hear the word quarterly, it means there's 4 parts to the year. So this is what we have for our APIN. So we have this for our APIN, 4,000, 0.65 divided by 4, which is that decimal. And then N equals 15 times 4, which is 60. So this is what we get for our A, P 1 plus I raised to the N. So you're going to get A is equal to 4,000 times 1.01625 raised to the 60. Let's see what we get for our final A value. In this case, A ends up being $10,521.88. Okay? And that's what we get for when we have a quarterly interest rate. So now, my question is, what happens when we have a monthly interest rate? Let's do that again for APIN. But now we're going to take a moment and we're going to actually zoom in on this because this is very, very important. All right, so if we're doing a monthly interest rate, so we have 0.065 and then we're going to divide that by 12. Now, if we go and use the full decimals for this interest rate, we're going to get 0.005416666. And then we're going to have 15 times 12 because it's 15 years times 12, which is going to be 180. So this is what we get for our monthly interest rate, which was divided by 12 from before, or multiplied by 12. So you got A, P, 1 plus I raised to the N. And we end up with A is equal to this. Okay? That ridiculous calculation. And when you punch that into your calculator, you're going to get $10,576.80. All right. So that's what you get for when you compound your interest monthly. Monthly. So now, what would happen if we calculate the interest weekly? So remember, we have our A, our P, our I, and our N. The P is still 4,000. The interest rate is 0.065, and the number of years is still 15, right? But because we're doing this weekly, we have 52 weeks in a year, don't we? So that means we're going to divide 0.65 by 52, and you're going to get 0.00125. Okay? And 15 times 52 is going to be 780 times that we kind of compound the money. So you're going to end up with A is equal to P. And then we have this substitute, which gives us this final answer. A is equal to $10,598.21. So let's zoom out and look at the results and the madness of all the stuff that we have just wrought. Okay? So here we go. Let's look at all the results. For all the results that we had, right? Kevin had $4,000, right? We started at just compounding at 15 times over 15 years. Then we changed the compounding period to quarterly, monthly, weekly, and to quarterly and monthly and weekly, right? And you'll notice that each one of the final values has increased very slightly. So what that tells us is this. When we increase the compounding periods, i.e., that's the N value, that means we increase the value of the investment. and you call that the final amount. Okay? So here is the last thing we need to study. Okay? So, summarizing all this information that we have here. Okay? When we talk about the various interest rates, right? When the interest rate increases, right? The value of the investment, increases. So the final value increases. When the interest rate decreases, that means it also decreases the value of the investment. Okay? Now, let's go and do this again. When we change the length of the investment, right? When the time increases, the value of the investment will increase. When we decrease the amount of time, the value of the investment decreases. So we decrease the value of the investment. When we increase how often we increase, when we increase the compounding amount, that means the value increases. We increases its value. And then finally, if we decrease how much we do this, right? If we decrease the number of compounding, right? So remember, we went from 15 all the way up to like 700 something, right? When we had a lower N value, that just decreased the value of the investment. Okay? And that's it. So your homework is page 450, 7, 8, 9, 10, 11, and 12. Good luck.